Hi, everybody. My name is Marcus. I work dev relations at Edge and Node, and welcome to the Graph Builders Office Hours number 40. And today we have two professionals from Semiotic Labs. We have Sam and also Ani, who have been working on the Graph and AI white paper and kind of planning the future, we'll call it, for the graph and AI and how it's really going to look for the next months, years, and to come. So it's really an exciting time in the graph ecosystem to see what's been going in their world and how they see the graph fit in Web3 as a whole. But before we get into the full introduction of Sam and Ani, I have a few announcements to go through that are important with the graph protocol ecosystem. So right now is the sunrise of the Graph Network. The sunrise of the Graph Network requires hosted service subgraphs to be upgraded to the Graph Network by June 12th. So we see this little banner up here. All subgraphs must upgrade within 12 days. Upgrade now. Here are the docs for upgrading an existing subgraph to the Graph Network. I will put this in chat in a second. And if there are upgrades about from the host service to the Graph Network, there is GRT available for any developer out there. Sunrise Upgrade Program. There are three specific missions to builders. Let me make this a little bigger on the screen here. The Web3 Builder Track, Web3 Builder Track, and Web3 Builder Track. People in this Discord are likely builders, so if you would like to earn some GRT, and it's actually a significant amount of GRT, go ahead and take a look at these missions. And if you want some more social missions, that's community engagement, those are cool too, but builders are here, so I want to talk about that. Another thing that is really cool that's going on right now is there are four new cookbooks that have just been released that go specifically to subgraph best practices. And there's four of them. They really improve, when implemented, query speed and indexing speed. And everyone wants faster responsiveness, better responsiveness with queries, and also the faster indexing speed. So these are the four best practices. Once again, I'll put these in chat. Go ahead and take a look at these best practices. As hosted service subgraphs are upgrading to the Graph Network, there are many more features to be added to these hosted service subgraphs that may be 2-3 years old. So make sure you take a look at these best practices as you're upgrading to the Graph Network to make sure your subgraph is the most performant. So with all that being said, let's transition into this talk, the graph as AI infrastructure. For anyone watching who hasn't read the AI infrastructure white paper, check out this link that I'll put in chat in a second. The graph as AI infrastructure blog post goes over a high-level overview of what this announcement is, as well as goes through what the authors of this paper, which includes Sam and Ani, have to say in the white paper. So all of these links will be in chat in just a second. That's all for announcements today. Let me transition over to Sam and Ani.
Yeah, I think I'll go first. So my name is Anirudh, or Ani, whatever you can pronounce is fine. So my background is actually in a subdomain of AI called multi-agent reinforcement learning. So I spent several years doing research in that area. Transitioned to working at the Graph a couple of years ago. And just really excited, I think, to bring AI to the Graph. Just given this is my background, this is sort of my passion. I'm excited to talk about this, excited to take your questions. Yeah, Sam.
Hey everyone. So just a little bit on my background. So I've been working in AI related areas since about 2010. It really was machine learning from about 2010 to 2015. And then I went and worked on a PhD, and my PhD was focused on AI, specifically reinforcement learning, which is behind some of the technique behind how we got different research groups got LLMs to work nicely. They used reinforcement learning. And so we're really excited that we're starting this more dedicated AI effort within the Graph, because that's what Ani and I have spent most of our careers working on. We're looking forward to the months ahead as we start building.
That's amazing. Well, let's get started. I want to start with just giving the audience a bit of background of Semiotic Labs and what Semiotic Labs is doing for the Graph protocol as a whole.
Sure. So, at a high level, Semiotic was brought in as a R&D core developer team. So we were brought in to focus on research and development. And we started in 2010. The company started in 2010, and during that time, we focused on privacy-preserving machine learning for Web 2 applications. And then we got involved. We started running an indexer in. I said 2010. The company started in 2020, focused on privacy-preserving machine learning. And then in 2021, we started running an indexer. And we also got involved in the Wave 1 grants. And by the end of 2021, we were working on grants related to AI. So we were doing a lot of simulation back then, and we built AutoAgora, Allocation Optimizer, and we were also involved with cryptography. So the company's been involved, focused on AI and cryptography from day one, and both outside of the graph and inside of the graph. And these days, we are trying to focus more and more of the company's efforts on bringing more AI capabilities to the graph, as you know, and verifiability efforts to the graph. And of course, today we're going to focus on the AI aspect of what we're doing.
Gotcha. And just for the audience to know a bit about you guys personally and what you guys are doing inside Semiotic, what are you focusing on, Ani, particularly in your day-to-day work? What part of the AI stack are you working on and integrating with the graph? And Sam, what part are you specifically working on?
I suspect the answer is going to be pretty similar for both of us. I think we're excited to transition, I think, a lot of our efforts towards the inference service that we talked about in the white paper. So in the near future, that's going to be, I think, our primary focus within AI. But we also have sort of other research efforts that we're currently working on. I think one is actually pretty close to being published. They're going to try to publish it at a conference. So there's other stuff we're working on, but graph focused, I think, is going to be the inference service.
Yeah, and on awesome. Oh, sorry, Marcus.
Oh, go ahead.
On my side, I end up doing a lot of project management and working on like priorities for the company. But like Ani said, I'll be deeply involved in the inference service as we build it out. I think at a high level, we are excited about the graph's position in this space, specifically because we have all this data. And data, there's a saying that data is queen in AI, and the graph has a ton of data. And it's going to be interesting to see how we use our data with AI services. And Ani's going to get into more detail about that.
Awesome. Yeah. Well, I mean, that is bringing up an interesting concept. You brought up the idea of position, and the graph is an interesting position for AI. So can we talk a little bit more about that? What do you mean by that?
Yeah. So there are quite a few decentralized AI projects starting or that have started in the past year. And the way most of them work is that you have, a decentralized protocol, and then you have workers in those protocols that typically have GPUs, and most of the time, what those protocols are doing is only competing with their Web 2 counterparts, which would be centralized, what we call AI model hosting, and the unique aspect of the graph. So those decentralized protocols, they don't have data. They require like an external user to send data to their protocol, this could be like a ChatGPT like query, and then that inference protocol would then run a model like an open source LLM, and or if the people had data, they would need to bring it from whatever their private database or wherever their data is stored, and use it with the AI service. The big differentiator with us, with the graph, is that we have the protocol. It has co-located, meaning we already have lots of data about many different blockchains, and we have basically, Ani and I, we worked on this white paper for 4 months, and we really banged our heads thinking about like, why is the graph interesting? Why is it interesting for the graph to compete in the AI space? Other than the fact that the market's hot right now. And over the past 4 months, we got a lot of conviction that it's our data and how we're going to use the data. And Ani's going to be talking more in detail. So I know that sounds vague, but I want to let Ani go into details about how we'll combine the AI services with the graph's data.
Yeah, I can hop into that now, or I don't know, Marcus, if there's if that's it.
Yeah. Yeah, let's go ahead and hop in. In the audience, we have a lot of builders who have a technical background, so I'm sure people here would love to see how you guys are doing what you're doing.
Awesome. So I guess to start with, I'm not sure how many people here have had a chance to read through the white paper, at least the main body of the white paper. So maybe just to start, a quick overview of what that is. So in the white paper, we're trying to do a few different things. We're trying to, first of all, what Sam was just talking about, motivate why we think the graph should be involved in AI, and then transition from that to talking about how we think the graph should be involved, given that, we buy our arguments for its involvement. And so we proposed two different AI services. One of them is the Inference service. Inference is just jargon for running an AI model. So if some of you guys are software engineers, it'd be the same. Like in code, you might say you're calling a function. In AI, you would say you're running inference, right? So similar concepts there. So the Inference service is really going to allow you to run sort of like a ChatGPT-like interface, or run other AI models that maybe do image stuff or reinforcement learning, calling out to Sam or my background. And then there's another thing that we're proposing, which is the agent service. And the agent service is really where we're trying to combine the graph's data with this Inference service. Sam has this analogy that I really like, where he calls the Inference service, or the AI piece, a brain. And then the agent service, the graph's data, etc. This is sort of like the observation, right? So you need eyes, you need senses for the brain to get this data. And then once you have this data, you can do interesting things with it. And that's really what the agent service is trying to enable. It's trying to enable these more complex applications. So at a very, very high level, that's sort of the main body of the paper. We also go into a few verifiability related topics and other stuff, but let me stop there and see if Sam has anything he wants to add, or if anyone has questions at that level.
I think, what about showing one of the diagrams for how our data will be combined with the Inference service? While Ani's doing that, this is just more philosophy, but as we bring AI into the protocol, we're basically enshrining intelligence into the graph, and we have concrete plans for where we're going to start, which are laid out in the white paper. But I think it's going to be really interesting to see what this does to the graph in the long term, to have intelligence built into the protocol. I think it could cause the graph to develop in an interesting and powerful direction in the long term.
That is fascinating. I love the phrasing of enshrining intelligence in the graph. That sounds great. So, Ani, let's go ahead and have you go through what you're showing us here right now.
Sure. So this diagram is an example of a SQL agent. So this is an example of the type of thing you'll be able to build using the agent service. So here we have, let's say, a user asking an AI gateway, give me the last 10 traits on Uniswap. The AI gateway passes this down to AI indexers who are connected to multiple AI models. They use the AI model to generate the correct SQL for this query. The AI gateway then passes this natively through its own sort of wiring to a SQL gateway, which passes it to SQL indexers. And so the end goal of this is to really lower the barrier of entry for people to create AI applications, right? So instead of managing this complex sort of workflow yourself, the sort of agent service is going to do a lot of this heavy lifting for you, and we'll have sort of a standardized interface for that that should work for a lot of different applications.
That's amazing. The question that I'm seeing in chat right now is from Lewis, and this applies right now, I believe, to this chart about the AI and the LLMs specifically. What LLM will the graph be using? Feels like there's so many LLMs to choose from Claude to GPT to Near onboarded within the graph as the home for user-owned AI. New models popping out every week, Mistral 7B, the new 6B, etc.
So we talk about this a bit in the paper. We're going to support any open model. So if you can find the weights for it, and obviously licenses permitting, just like subgraphs, how users can create their own subgraphs, we will allow people to upload their own AI models. Probably won't start there while we're ironing out a lot of the details. It'll probably be a bit of a controlled thing. But as we move forward, we will move towards an open ecosystem where anyone's allowed to contribute and share what they have with the community.
Yeah, upload. I can't see the names right now with my view, but yeah, be able to upload models.
Yeah, Lewis is also
models?
asking about uploading models and offline models. Yeah.
Yeah, sorry, Ani, I'll let you continue.
No, sorry. I that was it for me, unless you had something you want me to answer.
Okay. I think one thing that to clarify is that because the weights of GPT are not open, GPT-3 and on are not open, those won't be models that we can, or that any decentralized inference protocol can support. So it's only going to be open, or what is often called open source models. Might as well just get into the details here because this is a technical audience. Almost, well, I should say all of the foundation models, and by foundation models I mean Llama, Mixtral, all the popular ones you've heard of are what are called open models, which means that the model parameters are shared as like a file, but the training data is not shared. If like, let's say Facebook made Llama, the Llama family of models, if they released their training code and all the data they used to train Llama, then it would be called an open source model. But they don't release the training code and they don't release the training data. And that's why they're called open models. So they only release the model weights. That's why we call them open models. And we'll support all open models. So if you can get your hands on the weights, like Ani said, we'll support it.
Yeah, the only other restriction is going to be licensing, because for example, Mixtral's newest model is actually licensed under something that's a bit more restrictive. So the weights are open, but only for research purposes. You can't use it for products. So those would probably be. We're going to have to. These are sort of open questions in my mind, but we won't be able to support sort of product applications with things like those, obviously. So those are the two things: are like open models and then licenses.
Maybe what I could do now is Ani shared that diagram of how natural language to SQL could be enabled in the protocol natively, and I'd like to show an example, a demo that we made that does that, and so that'll give you a more concrete feel for what the types of tools that we'll be able to build. So
let's go for that. That sounds great.
All right, great. Give me just a moment. Okay, agency is a demo that we made to demonstrate natural language to SQL, and so I'll start by just showing you something. What's the daily average price of ETH, and why don't we just do BTC during the last month? So what's going on right now is I sent this question. This question got sent to an LLM, and that LLM generated this SQL. That SQL is then sent to a database that we populated using substreams, and if everything is working right, it's sent the answer to my query. So this is a type of application that the inference service is going to lead to us being able to build. And now, like right now, we don't do visualizations in this. Just I'm showing you a feature. You can download the CSV, and then you could then do deeper analysis. Let's say plotting of the results or the statistics on the results. And so this thing, you can answer a lot of different questions. It's pretty robust with how you ask questions. And the main value proposition of a tool like this is that it will make it so that people don't have to write SQL queries by hand in the future when they want SQL data from the graph. People will be able to come in the long term. The way that we see things is that people should be able to come to the graph and get any data they're looking for in their native language. And so that's the long term plan of where, well, that's one thing that we'll be able to unlock with this.
That's great. I get a question here about specific to agency. What's the LLM currently being used on agency? Any plans to get multiple ones?
Right now, because so like I said, we use substreams. We did some prototyping with substreams to like sync to a ClickHouse database, and we're using for the LLM, we're using GPT, and likely. Agency it was good for us to learn a lot of things, but we don't know or think it will become a standalone product at the moment. But once we get inference in the protocol, in the graph, we will likely point our queries to the graph's models so that we can have a stronger concrete demonstration of how something like this can be built on the graph. So GPT today, as soon as we get the inference service running, we'll likely point our queries to the graph as a demonstration.
Okay. Gotcha. That makes sense. I have a question about the actual product of agency. We have all these builders here. I'm curious between you two, as this is a kind of a demo of what you guys are envisioning. What could builders here do to help you guys out and play with agency or use agency? Is there any type of specific things that you are curious about how these builders might be able to interact with agency?
Yeah, Ani, so here's some alpha for the group. Starting next Wednesday, there's going to be a competition for the best use of agency. And we're going to use that to promote the AI services white paper. So if you on Wednesday, you'll see some announcements related to that, and there'll be like prize money for the best use of it. And I think basically we'll use Twitter as that's where the results entries will be submitted. So I think one thing that everybody here could do would be participate in that. And related to agency, we're going to be open sourcing agency, and so there's a lot of like techniques that we had to get develop to get good natural language to SQL working. And so you'll be able to use what we built. Agency is going to be open sourced, and like that may be interesting to the builders on the call. And then, maybe I'll just, Ani, do you have any other comments related to that question?
No. I think I'm going to leave it as a bit unanswered, just because I'm interested in seeing what people come up with during this competition. Right? I don't want to sort of give a leading answer and then get everyone giving us back the same thing.
Yeah.
That's great. I love a little bit of alpha. Let's back up a little bit. I'm curious about what this means for the indexers that have been indexing on the Graph Network for years now. They are specialized in running Graph Node, and they know a ton about the network, the tokenomics. I'm curious about what this future with AI will mean for them and how that relates to maybe how they were onboarded with the graph, with Graph Node and learning the tech. Was there any idea or can you have a comment on anything that you guys have in mind for what this might look like for indexers?
Yeah. So I think you actually said the key word in my mind, which is specialization. I think our existing indexers have a lot of expertise in sort of database optimization stuff. In the white paper, we sort of frame them as general compute providers, which I think is true. And, AI running inference is just another form of compute. So in the short term, indexers will be able to run AI models. In the long term, we expect that competition is actually going to encourage some amount of specialization here, where there are, similar to how we have database experts today, we'll have people who are experts in running AI models in the future. And so depending on the opportunities that an individual indexer sees, they might favor one side or the other more heavily. But that's sort of in the medium to longer term.
Yeah, and maybe to add to that, we're going to be we're going to be piloting the inference service, just like we run an indexer today. That's important for Semiotic so that we understand how the protocol works at deep level. We'll do the same thing for the inference service, and we're going to share as much as we can, everything we know, with everyone here, with the community, to help them get started.
I see a question that speaks specifically to the inference service from Mitchell. Will users have to pay for the inference service, something like the cost per token used with the GPT?
So, yeah, this is an interesting question. It's one that's sort of in our topics of things to figure out. So first thing I want to do maybe is differentiate or delineate between LLMs and inference, right? LLMs are a specific type of AI model which you can use for inference. You can also, there are a lot of other types of AI models that exist that you can also do inference for. And so my expectation is that for something like an LLM, something like price per token, similar to what you see with, let's say, ChatGPT would make sense. For other types of models, there's no concept of a token, right? Like it's very specific to recurrent neural networks, so the type of architecture of ChatGPT or LLMs. So for these other models, we would have a different pricing structure. So I guess my sort of hand-wavy answer is it's just going to depend on the model.
Gotcha. And also GRT being a functional token within Web3. I'm curious about how you guys feel about having a fully functional tokenomic model that is decentralized and operating well, and what that means in terms of your building. You already know so much about indexing and how GRT is used in the protocol. Are you thinking about that as you're thinking, how are we going to make decentralized AI work on the graph?
Yeah, I think part of our, we talk about this a little bit in the white paper, but part of what we see as our advantage is the fact that GRT exists, is the fact that the graph already has this set of economics that govern its use and that specifically serve to link up users with compute providers, indexers, right? So we see this as a distinct advantage. Any other protocol who wants to do something similar would have to come up with these economics from scratch. So of course, GRT is going to be, and the sort of economic infrastructure that the graph has is going to be tied together very tightly with our AI services.
And adding, just adding on to that a bit, we basically, in addition to having the tokenomics, we also have things like gateways. We know how to accept GRT. We know how to pay indexers in GRT. So there's so much infrastructure that's already built that we'll be able to use, that it is a relatively, compared to building a new decentralized AI infrastructure from scratch, it's almost a no-brainer for the graph to bring this on.
That's great. Yeah, I'm seeing a lot of decentralized AI out there, and just seeing competition, of course, is a good, healthy thing to know that we already have indexers around the world who are quite technical, and to know that we have you two, the Semiotic Labs team already considering their expertise, already looking at the tokenomic model. It seems like a no-brainer to me too. It's a really exciting thing just to see the graph heading in this direction. There's a question in chat here. How are you dealing with hallucinations at agency? Will you be doing with the graph? I've seen some amazing stuff with a couple top LLMs running GPT just to deal with hallucinations from a friend and colleague named Luigi Ottoboni.
So the way in the literature you actually deal with hallucinations is through external knowledge, right? So basically the reason that one of the reasons these LLMs hallucinate is just because you're not giving them like a book or something that they can refer against, right? Like they just have to memorize the entire internet and hope that they can recite it back to you. This is a tough ask. And so, one of the ways that we're hoping to really address this topic of hallucinations is by enabling what's called knowledge-enhanced large language models. So one of the ways we'll do this is via Geo. Geo is planning to build a knowledge graph. There are specific types of LLM architectures or LLM algorithms, let's say, called knowledge graph enhanced LLMs. I actually have a figure for that I can probably find if anyone is interested. But, conditioning the LLM's response on the actual data that it can look up is a great way to deal with hallucinations. And so that's something we'll encourage in the agent service. And in case anyone's curious about the figure, this is what it looks like. I can talk through this if anyone is interested, but if it's too technical, we can just leave it up on screen for a second and we can move on.
I think it's worth talking through. I think.
Yeah.
Let's go ahead and give it a go. You guys are here. I'd love to see what you guys have been working on.
Sure. So this is just an example Web3 knowledge graph. Here you could put in Geo in its place. So if someone asks a question like, "What is?"
Quick, can everyone see the screen, or is it just me right now? I'm unfortunately.
I can see it.
You can see it. Okay, this is just my computer. Then go ahead. Oh, Mitchell can't see it either. Okay, interesting.
Okay. I can stop sharing and retry.
Yeah, let's retry. Interesting. Some people can see it, some people can't. There we go. Okay, I can see it now.
We're good now?
If anyone can't see it in the audience, let me know.
Have we just switched who can see and who can't see? Okay, we're getting a lot of... It's looking good, so let me keep going. I'm assuming you guys can't see my mouse, though, right?
No, I don't see anything.
All right, that's fine. Okay.
I can see your mouse. Yeah, we can see it.
Oh, you can? Okay, cool.
Yes.
So let's say a user asks the question, what is the graph's token? The Web3 knowledge graph component here, you can just replace this with Geo. The way that knowledge graph LLM inference works is first you go through this information retrieval stage, which is essentially where you take this text and you try to extract relationships from this graph using graph algorithms. So you might extract this relationship from this knowledge graph where it says GRT is token of the graph, right? This is directly answering the question. So we call these things facts, right? It'll just be these various relationships that you can extract from the graph. This, of course, is not a nice, friendly format typically. So then there's this next stage of knowledge to text where you take this unfriendly information and reformat the text in this way. And this gives you what's called a knowledge description. So here you would get GRT is the token of the graph. And so basically these two things are then fed into the LLM. You get what is the graph's token and GRT is the token of the graph. Both those go into the LLM and the LLM obviously knows, okay, well, you've given me the answer, it's GRT. So this is an example of how you can get around hallucinations, right? It's this pulling in of external information, which is factual, which is accurate, that really sort of helps in this context. And you can see this used in the literature in a variety of places. People use it for like code generation, and a lot of other topics. So it's really, I think, the most powerful current way to deal with hallucinations.
It's making me think of, we're very aware of having data needing to be verifiable as it's piping through a substream, a subgraph, as we're looking at it after our GraphQL query has returned, making sure it's verifiable. And AI brings that interesting hallucination potential in there, and having that be a part of the creativity of AI, being able to have it be a supportive kind of concept as it's interacting with data that is state, that is on chain, that is recorded on chain. I'm sure that's brought up a lot of thoughts and questions for you guys on like, how do we do verifiability and how do we do it right? How do we make sure that anything that we report is actually correct in terms of hard data? But if there's anything, I don't know, I'm just curious about the conversations you two have had about verifiability and what that means in terms of what the returns are going to come back to people in the audience.
Sam, you want to take this one?
You bet.
You're there.
All right. Yeah. So, I guess there are a couple there. You had there's really two different questions here is the way I interpret this question. One is issues with hallucinations, and Ani gave the best answer I could give just a moment ago through knowledge enhanced LLMs, which also ties back to what I talked about earlier. That's the superpower of the graph, is that we have so much data and we're going to have a lot more data in the future. And combining that, you could see that combining that with LLMs is going to be able to take, we have the strength of the LLMs, and then we're going to enhance it with this factual knowledge, and that's going to reduce the hallucinations. So that's one thing. The other aspect of your question was about verifiability, and the way I think of a neural network, an LLM is a neural network, and a neural network is a mathematical function. When a neural network runs, it's predetermined it's just multiplications, additions, and a few other simple mathematical functions. And it's the same every time you run it. It's the same math that takes place, more or less. And the less part comes from intentional randomness, and that's where some of the creativity comes from. When you could send the same prompt to GPT and you'll get different results each time. And that randomness is pre-programmed using what's called a pseudo-random number generator. That pseudo-random number generator basically picks tokens from the LLM in a somewhat random way. So the way the LLMs work is they output a bunch of potential tokens, and one token is selected, and then that process continues on and on and on until the sentence is generated. And the process of picking these random numbers it boils down to a fixed seed, which is just a number, an integer that is used to seed the random number generator. And given the same seed and given the same neural network, then theoretically you will get the same sequence generated given the same prompt to the LLM. There are some weird there's some weird rounding issues of floating point arithmetic, which that make it in practice more difficult, but there's been some good work from a group called Aura, previously called HyperOracle, where they have shown they can get deterministic outputs from Llama. So, in practice, this is going to be a solvable problem. Now, for verifiability, the prerequisite is determinism, and that's what I was just talking about. How do you get deterministic output? Like if you wanted to dispute that an indexer didn't use the query that a user sent, or ran a different neural network, maybe a cheaper neural network, the prerequisite is determinism. After determinism, then we get to verifiability. So you want repeatable results. Okay, that's a prerequisite. We can get repeatable results. Now, once you have repeatable results, then how do you contest something like if a consumer disagrees? And there are different ways you can do this. One is using consensus. So imagine you have three indexers and like someone opens a dispute, and then the three indexers all run that query with the same random seed. And if they all match, then everything's good. So that's the consensus method. But then there's other methods too. For example, you can use refereed games. That has a lower. You only need one honest participant to use refereed games. And finally, at the hard mode is ZK proofs. And ZK proofs for modern LLMs are pretty much off the table because it could take like a day per inference. Like imagine you had to wait a day for your GPT query to return. That's where we're at with ZK right now. So really on the table for us for the graph is going to be like this what I call M out of N, meaning M indexers out of N indexers total, all agree on the same result, or refereed games. So those will be the two paths that we'll be exploring as we bring verifiability to the graph. So we're going to be working on determinism, deterministic outputs, and then we'll be working on these either consensus-based or refereed game-based, also called optimistic methods for verifiability for inference.
Amazing. So I'm going to have to read the white paper, listen back to what you're saying there, because it went a little bit over my head. But I do appreciate the answer. And for those of you in the audience that got that, I'm happy that you guys are here and just learning more about verifiability. That's just something that is going to be important for just really Web3 as a whole, and of course the graph, making sure this data is verifiable. So, I wanted to shift into bigger picture. We were going quite small and getting deeper and deeper and deeper. Let's back up a little bit. And I'm curious where you guys see the graph fitting in the Web3 space. Let's say everything that you guys are planning goes well and goes exactly how you guys are mapping out right now. Sometimes that doesn't happen as tech can go, but as of course, it could possibly work everything beautifully, exactly how it was designed. Let's say everything goes beautifully, exactly how it was designed, and we're a year out. What does this mean for builders in the graph protocol and the graph ecosystem, as well as what does this mean for the graph and how it fits within Web3 as a whole?
Well, at a high level, we see AI as having its biggest impact on user experience, and by that, I already talked about using, like, let's say natural language as SQL, or for the graph, we'll have many data services in the future, so we could just abstract it to natural language to queries. So in the future, we expect that there will be more and more front ends in Web3 that will use data that is going to have natural language queries. I think we expect to see this in Web 2, right? I mean, we're getting natural language interfaces all over Web 2, and we expect the same thing to happen in Web 3, and that the graph will be serving many of those applications. And then, what UX is such, it's an abstract word, but if we go further, then we start getting into the agent data service. And this isn't something we've talked much about in this talk, but it's in the white paper. And this is about basically simplifying all interactions in Web3, not just doing a query for some data, but it could be things like, let's say, imagine a user comes to the graph and says, there's a little chat interface, and they say, oh, I would like to delegate on the graph. And then basically that whole experience from their question to it being done can all be automated, and it'll actually be powered by the graph itself using the AI, Inference, and the agent services. And these capabilities, what we're building is a general capability that would allow, let's say, one of the core developers to build this sort of like chat to delegate functionality, and that same underlying functionality that's enabled by the Inference and agent services would be usable by other Web3 protocols. So they would be able to have this just much more just easier to use interface for their protocols, and that it would be powered by the graph. I think Ani has an example.
Yeah, just to tack onto this, I think depending on which part of the crypto space you're in normally, you might have heard the term Internet of Agents tossed around a little bit. It's this concept where in the future, most of Web3 will actually just be populated by automated agents of various types. And users are just going to be interacting with these agents via natural language or whatever sort of front-end UX best suits them for their particular application. And I think we agree with this vision. So we have a couple examples about how we think we would, how we think the community can enable this using the AI services that we've proposed, the inference service and the agent service. And so Sam was talking about this delegation example. So this is an example. If you've ever heard the term intents just means using natural language to express an intent to do something. And then various agents will take over and figure out how to actually execute that for you. So this is just an example with, you can see there are a lot of agents here. The ones that aren't sort of highlighted are just not used in this flow. But they still exist within the graph in this theoretical future. So these are asked to query delegate 1,000 GRT to an indexer. The intents agent sort of parses that and figures out, okay, well, this is actually probably a question for the graph. So there's a graph agent. It's just going to pass the message along to this graph agent. The graph agent would have a delegator agent, and this delegator agent is very specialized. It knows exactly when you say, I want to delegate 1,000 GRT, here's what I need to do. And so there's sort of other examples that we can give of this in the DeFi case, in DAOs, in whatever other sort of application you might think of. But I think the core idea here is that we really see the future of Web3 as being populated by these agents. And we make an argument for this in the paper, in the appendix of the paper, but we think that the graph is going to be a central part of a lot of this infrastructure.
Yeah, that idea of the graph and being a central part of this infrastructure, all of these agents in Web3, all of this AI being decentralized, and then the elephant is in the room is, of course, the centralized AIs out there that are the Microsofts, the Googles. One final question from me about Web3 and Web2 and AI. After putting so much thought into this white paper, after really seeing where the graph is today and where it might be a year or two, and then comparing that to the centralized AI services out there, I see. I'm just curious what you guys feel about the values therein with Web3 and how important it is to maintain this decentralization in regards to this compute. So far, there hasn't been compute at this level, at this speed. What is this going to mean for the future in terms of a potential centralized force of AI versus a decentralized force of AI many years from now?
I'll take an initial shot at this. So, in general, the more compute you can throw at AI, the more powerful the AI system is going to be. So, I don't expect the open source community to be able to the decentralized community to be able to train models that are as sophisticated as the models that are going to be trained internally at OpenAI or trained using Meta's massive centralized compute capabilities. And there's a bunch of technical reasons why training is difficult in a decentralized way. A lot of it has to do with like how the updates to the model are passed around in a decentralized way. That being said, something that we've seen with AI over the past 10 years is that for any given level of performance, let's just say GPT-4.0, which is the latest, it becomes year after year, you have researchers who are trying to figure out how to use less data and less compute to get to that same level of performance. So we will have decentralized. Eventually, decentralized techniques will get to like GPT-4.0 capability. But by that time, by the time the decentralized training community gets there, GPT may be at like 6 or something. Who knows? So there's going to be lag in the training aspect, the training aspect of things. But I also expect that there's going to continue to be competition among like Meta and other companies to release open models, kind of just like, that's that's how they differentiate, for example, from the closed models, is by just opening them. So we'll continue to get access to state-of-the-art models. It's just that the open community won't be designing state-of-the-art models. Ani, do you have any agreements, disagreements on that?
Yeah, so I think on this question, I'm linking 2 papers in the chat in case anyone is interested. On this question about like what is the future of these large language or large generative models in general, the research community is pretty split between whether we think that more data and more compute is actually going to be helpful or not. So I just linked 2 papers on opposite sides of the spectrum, right? So the first paper that I linked basically says that they run a bunch of experiments and they say, no way, you're going to keep scaling up compute, you're going to keep scaling up data, and you're going to get sort of diminishing returns. And the other paper goes in the opposite direction a little bit. It talks about how you're already starting to see the sort of you're starting to see sparks of artificial general intelligence, like the total sort of AI that you see in like a Hollywood movie or something like that. You're already starting to see this in GPT-4, and as we continue to develop these models, it's just going to get stronger and stronger and take over. So there are sort of 2, I guess my answer is a bit 50-50, just because I don't know, because the research community is pretty split on this question about whether this sort of larger and larger models is going to be useful, whether it's going to continue to improve. I think the bet that we make in the white paper is that actually splitting these up into smaller agents that are more specialized is actually going to be, at least for the Web3 community, at least for the open source community, a lot more tractable and sustainable. And so instead of having, if I pull up this diagram again, like you could conceivably have one model that does all of this, right? It's going to be super difficult to train. You're going to need a ton of data. You're going to need to run a ton of just like training time and everything, compute, etc. Or you can create 100 of these smaller agents that are very specialized and then that can pass information around to each other. And this is very tractable. This is totally doable. It's called a hierarchical, in the literature it'd be called hierarchical reinforcement learning. We call it hierarchical agent trees here. This is totally doable. And this doesn't require this sort of mentality that we're going to be sort of trapped by the fact that we don't have the compute to compete against a Google or a Meta or whomever, right? So this is sort of the direction that I see us moving in the future. And if the AGI people turn out to be correct, if the second paper that I posted, if that camp of researchers turns out to be correct, then I hope Sam's right and that they will continue to open up all these models for the rest of us to use.
And maybe adding on to what Ani just said, with the hierarchical agents tree philosophy, where you may have many small models specialized in their given task. We've already seen, we already know that these small models, if they're specialized, can perform just as well as GPT, which is a foundation model. It can do anything. And so we know that we can build small models, and on top of that, it's very expensive. If you compare the cost of running GPT to let's say Llama 3. I don't know the exact cost because they don't publish it, but I would expect that Llama 3 is 1 or 2 orders of magnitude cheaper, maybe more, to run. So in terms of latency, power, compute cycles, cheaper on all of those aspects. And so there are benefits to using these small models, and you can get, for specialized tasks, you can get the same performance or better.
That's fascinating. I'm just very excited to see these next few months. I mean, I've been playing with GPT-4o, I've been playing with Perplexity, and playing with a few different models. I played with a llama a little while ago, and it's just really exciting time just to see what's going on. So with that being said, we're coming up to an hour, and I just want to leave these last few minutes for you two and to say if there's anything that we missed that maybe in terms of links or how to reach out to you, or maybe if there's any actionable items you'd like for those listeners out there, the stage is yours for the end of the Graph Builders office hours. Take it away.
I'll just reiterate that I think the next step here for us is we're going to be doing this competition with agency next week, if you weren't on the call earlier, and that's to basically who has the best use of agency. Submissions will be done on Twitter, and so please watch for Wednesday for that announcement when it kicks off, and that's going to be used to drive awareness of the AI services white paper. And then I'm personally interested in talking to people who have ideas already of what, if they have ideas of something that they'd like to build using the AI services. I'd love to talk to you. Ani, do you have anything to add?
Yeah, I'll just add that I appreciate everyone's time and questions. I think, especially for Sam and me, coming from an AI background, sometimes we can say something that's a bit technical or just not realize it and go over it. So especially the questions help us understand where we're being unclear. And so if you have more questions, I think there's a Graph AI channel on the Graph Protocol Discord server that you can join and ask us there. And at some point, we'll probably put together some sort of an FAQ with a lot of these questions. So, just keep the questions coming.
Awesome. Well, thank you so much, you two. I appreciate your time, your expertise, your effort, and your many years of work towards improving AI. That is really an impressive task, especially in a decentralized manner with the graph. I'm very thankful for what you guys do. So with that being said, thank you everyone for attending another episode of the Graph Builders Office Hours. We'll be here next week as well, 5 p.m. UTC, and keep on looking out for what Semiotic Labs is doing in the graph ecosystem. So everyone, have a good rest of your day. Take care.